Alright, so in this tutorial I'm going to show you guys a quick way to make heat distortion using particles in Houdini and then rendering those out, then bring them into Nuke to apply on top of other effects and add a layer of detail to your renders and your comps. So to get started real quick, just go ahead and drop down a geo node and dive right in. In that geo node, just delete the file and add a tube. On this tube we're going to do a little trick, so we change it to a polygon. Change the rows to 8, columns to 32. If we change the first radius here to 0 and the height to 0, we get a disk. The disk has a lot of nice concentric circles, a lot of points to play with when we are emitting particles. And then one thing I make note of is that in the center there are 2 points. We don't want that. We do not want overlapping points. So just take a fuse node real quick, drop that down, and if you look back at them, gone. Awesome. You can drop down a null for just clarity's sake. Now this is the end of our input geo in a way, so we can name that in geo. If we want to get fancy, we can just go ahead and do some nice cleanup, color it, a bit easier to see and find. Awesome. So then we will drop down a wrangle. I use aptitude wrangles for this, it's fine. And we can start setting up velocities. So go ahead and name it something like create velocity. Alright, and in here, just for testing purposes, we can do v at v equals bracket 0, 1, 0, and end it with a semicolon. And then you won't see anything update automatically, but if you drop down a visualize node, which are great little tools to use, look at it, and right now if you go to visualizers tab, it's looking at the point position attribute. You can just change that to V, we get green. But then if we change type to marker and style to vector, we get a vector that shows us that we do in fact have velocities pointing in the y direction. And it's about a 1, so it looks like a normalized length, which is fine. So we can go ahead and drop down a null at the end after, not there, right there. So after create velocity, and call it out particle source, color black, clarity's sake again, and we can go ahead and start playing in the simulation and see what we get. Name this particle source. And I gotta add an S. Cool. I've dropped down a DOP network. So we are simulation. We just quickly name this particle sim. Dive right in. We'll need 3 things here. For a start, we need a pop solver. We can plug that in right there. Ooh. Need a pop object. And then we need a pop source. There we go, pop source. And we can, on the pop source, just go in here to the stop path and go click export relative and then go find our particle source, out particle source. And if we capitalize out here, it should be near the top. So accept. We'll see we're getting some particles here. It's great. Now if we just go ahead and turn on real-time mode and play this, we'll see that we in fact have particles moving at about 1 meter per second in the y direction. It's kind of boring, no life to it. We can fix that. So, first things first, before we even start messing with the simulation here, let's go back into our source. Now, when we instantiated the velocity, we did it with a velocity of 1 in the y direction. But what we want to do is we want more life to it. We want to give it some variation, be able to like control the velocities off the front. So one of the ways I can show you to do this is on this disk, since you have a lot of nice points here, we can start getting ramps from the center to the outside, and we can have an overall multiplier of the amplitude. And so let's quickly just float amp equals chf amp, and that'll instantiate a channel for the amplitude. And if we do float vel ramp equals ch ramp velocity ramp, and we're going to have a variable called IDW, which I'm going to define in just a second. Now what IDW is inverse distance weighted. So IDW And what this does is I will feed it a center point and the current point along on one of these current points here, in the position of that point. So from the center point position to one of these points position, find out the distance, and then 1 minus that distance will give us a value between 1 and 0, and that'll build us a ramp from the center point to the outside. And if you have, so this works simply here with 1 minus because the radius of this disk is 1. But if you have a changing disk radius or anything, you're going to want to make sure that you update your formula, or you get a reference to the radius so it automatically updates in your wrangle node here. So right now it's 1 minus distance at P, and then we also need a center variable, so just do vector center equals 0, 0, 0. You could just plug this in here afterwards. Either one. I like to call it out very verbosely at the top, so we just do center. And then rebuild, you see that, and if you want to see if that's working or not, just quickly do, for testing purposes, cd equals idw. And then we can get a good visualization of that ramp. So we have a value of 1 here at the center point and 0 here, and everything in between as we move in. So that's great. And if you add more points and more rows and columns to the tube object at the top here, you'll get more data, and you'll get a lot more velocity to play with, and you'll be able to see the shaping of that velocity. But this will be fine for right now. So just get rid of this real quick. Don't need that. And then we just need to rebuild the velocity a little bit. So at v.y, we really need to affect the velocity in the y direction. Multiply equals amp, or let's do vel ramp times amp. Now when we do this, it's going to pretty much kill the velocity of the particles. But we just need to make sure we hit this button here to create those channels, the amplitude and the vel ramp. Set amp to 1 for now, so we can see it's coming back a little bit. And vel ramp is this. So if we go to the visualize node again, you can quickly see what we did. Now the velocities in the edge are 0, velocities in the centers are 1. That's pretty cool. And then all that is controlled by here. So if we want more velocity in the edge, like just a little bit, we can bring up this point of the left, and then we can just kind of figure out what we want this to look like. You know, something interesting, maybe just do something more like this. I don't know, something funky. All right, that might be more interesting than the basics. And then we can jack up the amplitude. So say we want this to be more like a thruster or something, we can put it up to like 500, see what happens, and you can see our velocities get quite long. That's fine, we can deal with that. Now just go back and set it to our particle source. I need to turn that off. All right. Now in particle sim, something to kind of keep it clean looking on the first frame, what I do is I at least set it to $FF greater than 0, or greater than 1, I should say. So on the first frame, nothing gets created. And this also can be an effective when your effect starts as well. So if you have these particles being affected by a fluid, and you're using those to drive the heat distortion, then this wouldn't matter. But for this case, I just keep it clean on the first frame, and we can quickly play that and see. In fact, we're getting particles flying out to nowhere and not really giving us any good look to our sim. So first thing we can do is we can drop down life inspect and do something like 0.5, give it a bit of a jitter. So 0.5, 0.2. And then I usually set these substeps up a little bit. It's just in case velocities get too fast. Alright, now we can tweak these all we want, but what we really want to get into is adding some other particle nodes. So like pop force, we can drop one of those down. That'll help give us a bit of noise in there, but we also would want a pop drag. Now pop drag is going to make it so these particles don't quite go as far as they will hit air resistance. So off the bat we can see that just with that pop drag and a bit of a life, we're getting a much tighter simulation. And you can see they're getting a little bit slow in the end, they're really fast here. So you can kind of tweak these out and see, if you go to pop drag, use vex expressions, and stop this. We can drop down here, pass through, air resist, yep, times at an age. So what that will do is as it get older, air resistance will take more of effect, and so this is it's a bit more stretched out now. You can kind of tweak this down as well if you just want to make air resistance a little bit higher, or you can edit it here and add an age times like 2 or something, and that will help kind of tighten it up a little bit as well. It's up to your preference. I'm going to do that, but I'm also going to tweak the air resistance by 1 here, and that'll give us something a little more. Yeah, I mean, you also got to think about we do want to add motion blur to these, so there won't be a lot of motion blur up top here, and we can kind of play with that, or you could also just go back in and change these birth values to something like 2 and 0.1, and then you can bring down your drag so it's only 1 again, and then maybe you play it and just not going as far anymore, but you can see they're faster up top because they're just dying quicker, so that's all good and dandy. Then we can do amplitude like 10 or something here to get crazy, scroll size like 2, I don't know, pulse length of 0.25, something fast, something wicked, I don't know, anything you want. Give a little bit of jitter to it, so if you turn that off, turn it back on, and replay it and resim, you should see a bit of a difference there, but you see a little bit, it's like whipping back and forth with the tip there, which is nice. Nice little motion at the end. And if we even want to, we can do the same thing here, where we pass through these values in amp at times at an age. So at the very tip we're getting a lot more, and then we can probably amplitude 20 to make sure that we're getting enough. Yeah. So it's just nice so that it's more streamlined and less noise at the bottom, but definitely get a lot more at the tip there as they get older. And we can kind of push the noise in the Y direction as well. Alright. Next we want to make sure of is that we're setting a pop color. So if we drop down pop color node, we just sim out to say 24 or so. We have a constant, we want to change that to a ramp. And you see it's ramping based upon the normalized age, which we don't want. We want to ramp it on a random value. But to do a random value with particles, we want to make sure we use the @ID variable, so that it'll be the ID of the particle, and this is a unique ID to each particle, so when they die, it won't get reset, and there won't be a bunch of jumping as each particle dies, which is what we want here. So just add a random integer at the end there to make sure that we get something a little bit different than the ID just by its own. It's like a seed value. All right, now if we play that, we can see black to white. It's getting kind of random, but what we want to bring in the Nuke is values that are between pure red, so 1 red, and pure green, so 1 green. And it always kind of seems like red's a little underrepresented here, because there's a lot of green values, so I usually just kind of bring this out a little bit this way. It's a little more even. Cool. That's pretty much what we need from the start, but there's one more thing. We got to make sure we have particle sizes set up. So we can set up a pop wrangle, and in that wrangle we want to set the p scale, so at p scale equals something like 0.1 maybe, but we also want to do here is we want something random. We want not random, we want something to kind of scale up and get a little more random. So we need a couple things. We need a random actually, so let's also do ID and then another random integer seed value, and then float. We need a ramp here is what I like to do, so I can kind of make them small make them smaller at the end and then small at the beginning, but like larger in the middle. So we can do a size ramp, float size ramp equals ch ramp size ramp, and this one just has to be based upon normalized age. So do that, and then we can quickly just kind of slug these in here. Equals size ramp times random times 0.0, it's 2.05, and then we can quickly make those. We'll see the ramp here, and then we want to do some editing here real quick. So as they get older, they kind of start small, but they quickly get bigger. and then at the end we want them to die off to 0, and then we can feather these values out at the end here so that it's a little more clean. Alright, maybe we want to edit this so it's there. Cool. Now if we resim and we kind of do a quick render, maybe just for ease of use, make sure we get something that we're going to get at the end. Put down a ROP network, mantra node. Let's set it to rendering enable motion blur. And we can probably edit this real quick to something like heat distortion. .f4 for make sure we're padding a 4 on the frame number, render frame range, things like that. And then I always like to set the sampling here to 4:4. It's a bit cleaner of an image. It should be fine for rendering a quick test on this later once we have it all set up. And then we go back to our scene view. Want to drop the camera down real quick, and just control click camera there, create the camera, lock it, and in the view tab, since it's a vertical simulation, I just like to set resolution to 1080 by 1920 so that we have a vertical aperture, or not aperture. You have a vertical view here, whatever. And we can kind of line it up real quick. And then when we bring it into Nuke, we'll just basically rotate it with a reformat node, and it'll be all horizontal and nice looking. So if we do a quick render, we can set this to monitor 1 and our camera 1, turn off preview, render. We see, yeah, we're getting a bunch of different size particles. We're getting a nice color gradient in there, and we're getting smaller ones at the beginning. So what we need to start tweaking to make sure this doesn't happen. One thing we can do is we're not really emitting that many particles at all. So just change this to like 20,000. 20,000. Then it'll be a few more particles, and then if we tweak these in a little bit so it ramps a bit faster here, it's great. And then we can change this to something. Let's just kind of restart the render, see what that looks like, and then we can tweak some more values. Ooh, something had to have changed. Oh, I gotta resim. Alright, cool. Yeah, simming on this doesn't take a lot because it's literally just particles, so one benefit of this using this kind of system. It doesn't take a lot to sim. Alright, so we're still getting some chunkiness in there. We can kind of keep playing with it. Maybe at the end here we want these particles to die off faster. So like we're getting these really big ones at the end. Maybe we don't want that at all. Maybe we want them to kind of fall off like that. So we want these to get bigger faster. So another thing we can do is just go ahead and change this value up here a little bit to maybe like 0.35. We can resim. Maybe just even give these more particles, something like 30,000. So keep giving it particles until there's no more particles to give it. Alright, and then let's render that again. Ooh, there we go. It's a bit tighter now because there's more particles and they're smaller, but this will give us a bit more interesting distortion as there would be more values that are blended between, and this should look a lot nicer than those chunkier large particles. Cool. So we can make sure our cameras see it all. Yep. And then the next thing we got to do really is we don't want to render directly from the sim. We want to bring those into a geo so they can have blur on them. Before I do that, I need to go jump back into source because I did forget one thing. Go here, move these up, and add a trail node to this here. Set it to compute velocity, and that'll enable us to get motion blur. So we just add another geo at the top level here. Call it particle export. Quickly dive in, delete the file node, put down a .io node. And that .io to point it to the particle sim, and then the pop object. Export relative as always. In the presets, you can go ahead and choose particles, and you can see it automatically just brings them in. It should have all the data, and drop down a null. The output of that. Yep. do out particles. If I don't spell it wrong, I can't even see what I'm typing. There we go. That's fine. I'll live with that. Then we can put down a shop net. So the shop net, we're going to need to assign a constant shader. So if we quickly go to our material palette, scroll down till we find constant here under utility, expand this shop net we just created, drop it in there. So in our object level, we can particle export, two things. Go to material tab, click here, we can dig down into the shop net here and apply this constant with the relative path. And under render, go to sampling, turn on geometry velocity blur. That will give us motion blur on these particles. So if we render these now, so we had this before, so I can even just save a snap, and we just render it again, you're seeing now we get a lot of motion blur on these particles through the whole thing, and there's no like shining or specularity to them, and they're basically just flat values, which is exactly what we want. We can kind of boop boop, yeah, much better on the second one. Motion blur and Nuke, you pretty much need these flat values to bring in Nuke. So bad, good, awesome. That's pretty much it. So a couple things you want to be aware of. You want to make sure you go to your ROPNet, your monitor node, set this to render frame range. So you're running the whole frame range, and know that it's going to output to a local directory based upon this. So if you middle click here, these are going to be rendered to basically my desktop or my users folder. So just make sure your hit file here is saved to a location, and then like in its own folder, and then they'll get it all encapsulated. So that's nice. And that's pretty much it. I'm going to go ahead and jump over to Nuke now, so I'll see you guys in a minute. Alright, so now that we're in Nuke here, we can go ahead and start setting up a few things in our scene real quick. So we want to make sure that we have it in a 1080 format here. And then we can hit script directory to make sure we pop this in, so when we do our read node, we can make it a relative path. And so what I'll do is I'll quickly just copy this path here, drop it on read node, and I can just drop that there and look under render. So I have the Houdini file in here, which I didn't name, so you should probably name that. Don't be like me. And I can pull in the heat distortion sequence we just rendered. Oops. Hit 1 to look at it. If I just kind of blow that up. Oh, nope, don't do that. Quickly, so we got this. So that's what we rendered out of Nuke or Houdini, and we brought it in here. It looks great. It's cool. So a couple things we want to do. So in the however we want to distort this, we're going to put it over a checkerboard, so we can drop one of those down real quick. A checkerboard here. Things we make sure of. Let's say we need to reformat our footage here. So right now we want to reformat like this. So set resize type to none. You turn it to turn, and we can just flip it, so left to right. And we can just go ahead and merge that over. We'll just look at what we have. So ARB, doop doop doop, and we'll see it's right over top there. So it's definitely workable. And we just can get rid of that because we actually don't want that, but just to see where how it lines up. What we want to do in the distort node, for the iDistort node, we want to be able to feed it channels that have red and green values from -1 to 1. So the way I've been taking care of this is with the lookup node, so or color lookup, yeah. Let's call them color lookup nodes. And so you can go in here, just look at it, quick, and hit the red channel, and then if you go here, drop Y to -1, and you go to green, do the same thing. And I usually do the same thing to blue for ease of use. Make sure like all values are clamped to fit to those range. And then if we go in here, if we look at the readout, we can see that the green values and the red values are both from positive and negative, so it's what we want. It's good. And then we can have the reformat. Then we also want to do should be a blur node here. Now, blur node, the reason we're doing this will become more apparent once we start distorting. So let's kind of leave it there and put it at something like 8. And then we're going to start kind of bringing values over. So the easiest way to do this quickly is just take a copy node, copy channels A to the B pipe here, look at it, and so I want to copy the red values, the green values, and the alpha values of this, of the A. So from the A channels to the B. So what we want to put those into is a channel that can hold these kind of values, but can't really put them to the RGBA. We can't, there's really no good channels here. So it's quick and easy to create a new one. It's called distort.red. And it'll ask you if you want to create a new channel, so you just go ahead and say yes. And you can keep doing that, so distort.green. And then it won't ask you the second time because it knows the syntax is, you know, the channel name plus the subchannel. So if you just distort.alpha, and then that'll copy all over, which is great. We can look at this and you don't really see anything here. But last thing we need to do is just drop down iDistort node. And that iDistort, if we just go ahead and look at that, set UV channels to distort channel we just created, you can start to see slightly shifted. You can kind of change the UV scale to something like 15. It becomes very apparent, like the changes that we're dealing with here. And then you can, the reason so I can show you the blur while we did the blur earlier. So if I turn off, if I hit D, the blur, and cancel it, you can see it gets really kind of jagged, and there's a lot of like artifacting in there. So we just hit it with a slight blur to kind of smooth all that motion out. And another thing you'll notice is this. These weird shifted edges, and that's a direct result of us using this color lookup. But if you also kind of turn that on and off, you can see why we're using it. So if we don't have that color lookup, all the values are getting pushed in -x and -y. But when we have the color lookup on, the values start to shift in both directions, which is what we want, because heat distortion will move in positive, negative x and y. And so we just want to make sure we have that color lookup to do that. And so in the iDistort, to get rid of this kind of weird edge artifacting, all you really need to do is go into the mask channel and hit distort alpha. And it'll bring it and clamp it right to that edge of the distortion we just had. And you can, the blur here, so if you change blur to like something like distort alpha, you'll see the blur here really just gets rid of detail. So if you have a blur that's kind of look you're going for, that's where you want to do it, but I don't like to turn this on too heavy. Like 1 is pretty much enough for me. Just give something so it's a little, maybe 2, so it's not so apparent what's there. But I always like to keep that pretty low, because I don't really like having it hazed out. But if it's a hazy, like that's how you get a bit more haze in there. And so we can quickly just kind of look at this and show the result of quick heat distortion setup in Nuke here. Let me just go back to the beginning. That should be a bit slower to play because it has to like copy all the channels over and then distort it. But we can directly see the effect here if we just kind of show this first bit off. You know, since the motion blur at the front end here is heavier, we're getting like streakier, and so a lot of the distortion is a bit faster, and you can really kind of feel the velocities in the motion blur as well. So it's really nice, or in the heat distortion as well. My bad, which is nice. So. And the real benefits of this, so if you have like a ship or something, or you have flames that are following something, and they're like something, I'm thinking like a flaming rock being flung from a trebuchet right now. You have like distortion behind it because you want it. What good thing about this is that the scale of distortion will follow, and it'll follow that object, and it won't be a constant scale, or it won't be like a layer of noise that you're trying to have to constantly scale in to make it match. This will always match to your scene. This will always kind of fit. As long as you have your settings in Houdini and your particles set up correctly and they look good there, you bring in a Nuke, it'll all fit, it'll all sit right. And it just follows along, just like a regular particle sim. So we can just go ahead and play this whole sequence and we're getting something really nice. And maybe you can like tune this down so like there's less, maybe that's something you need, maybe just like tune these back. And it's all pretty flexible at this point too, just kind of tuning values and channels. And that's pretty much it. Write this out, put this over your footage, do whatever you need to do with this. So I hope you enjoyed these tutorials, and I will package up these files and provide them alongside. So if you want to dig through them again, that helps. I'll be glad to provide those. So thank you.